Hey everyone, and welcome. Today, we're going deep on one of the most essential but often overlooked pieces of tech inside every single device you own. We're talking about read-only memory, or as you probably know it, ROM. Let's dive right in.
So have you ever really thought about that? I mean, your computer's totally off, no power, nothing. And yet, you hit the power button, and it just knows what to do. It knows how to wake up. How is that possible? It feels a little like magic, right? Well, it's not magic. It's a very specific and very cool piece of technology. And that technology is ROM. You can really think of it as the computer's built-in permanent instinct. It's the one thing it can never, ever forget no matter what happens. All right, so let's peel back the curtain on this startup secret. We're going to look at where the most fundamental, the most critical, and totally unchangeable instructions for your device actually live.
Okay, the two big key words you got to remember here are non-volatile and permanently. Non-volatile is just a fancy way of saying it holds onto its data even when you unplug it. Unlike its famous cousin, RAM, which basically gets a total mind wipe every single time you reboot, ROM remembers.
And this quote from our source material, wow, it just nails it. Without ROM, a computer is essentially brain dead. That's because it holds the BIOS, the basic input/output system. Think of that as the first piece of software your computer ever runs. It's what wakes everything up, tests the hardware, and gets the main operating system loaded. Without it, you've just got a box of parts.
So these core features are what make ROM so incredibly reliable. The fact that the data is read-only is huge. It means it can't be accidentally messed with or corrupted by a virus. This is what guarantees that the boot-up process is stable, secure, and works the same way every single time.
But here's where it gets really interesting. ROM isn't just one single thing. Oh no. It's a whole family of technologies that has been evolving for decades. So let's take a quick look at that evolutionary journey. This slide basically tells an amazing story of innovation. I mean, we started way back with MROM, where the data was literally baked into the chip at the factory. It was set in stone. Then we got PROM, which was like a blank CD. You could write to it exactly once, and that was it. The next big leap was EEPROM, which was wild because you could actually erase it by blasting it with UV light and then start over. But the real game changer was EEPROM. Suddenly, you could erase and rewrite the data just using electricity. And that technology led us directly to today's champion, flash memory. It's a faster, way more flexible version of EEPROM that's in pretty much everything now. Your SSDs, your phone, your USB drives, you name it.
And that brings us right to the present. Now, you might not walk around thinking about ROM, but I guarantee you interact with it dozens, maybe even hundreds of times every single day.
So, why is this stuff literally everywhere? Well, because it's the perfect tool for the job. It's designed to hold firmware. That's the permanent software that tells the hardware how to work. And as you can see, it's not just reliable and secure, but its simpler design makes it way cheaper than RAM. That makes it the perfect choice for everything, from a super complex computer to your simple washing machine. I mean, just look at this list. Its reach is incredible. The basic instructions in your microwave or your TV remote, that's ROM. The BIOS that kicks your computer into gear, a modern EEPROM. You remember those old video game cartridges? Classic ROM. And of course, all the storage in your USB drive or your fancy new SSD, that's flash memory, the newest, most advanced member of the ROM family. Okay, now for the final, crucial piece of the puzzle. To really, truly get what ROM is all about, you have to see how it stacks up against its partner in crime, RAM. And here is probably the best and simplest way to think about it. RAM is your active workspace. It's a temporary whiteboard that you're constantly writing on and erasing as you go. ROM, on the other hand, is like a permanently printed instruction manual. It's the book that tells you how to even get started in the first place.
And when you put them side by side like this, the differences are just crystal clear. RAM is temporary, ROM is permanent. RAM is volatile, it forgets everything when the power is off, while ROM is non-volatile, so it always remembers. RAM is all about what your computer is doing right now. ROM is about the fundamental instructions it always needs. One's a sprinter, the other's a librarian. And you absolutely need both for anything to work.
So, from these old factory-set chips to the rewritable flash memory that we carry around in our pockets, ROM has been the silent, steady heartbeat of computing. But as our tech gets even smarter, the lines between temporary and permanent memory are actually starting to blur. So the real question for the future is this: will we one day have a single, unified type of memory that can finally do it all? It's something to think about. Thanks for joining me for this explain.